Okay, this is Algebra 2, session number 2. Today's the 17th all day long. I'm here with 1,000 of my most irresponsible students that decided to waste 15 weeks of the semester and are now going to try and learn all of this in 3 hours. Just kidding. They're responsible. That's why they're here. For the record, I'm not holding them hostage. They are here of their own free will. I am merely offering my time, and they have taken me up on it. We will start with whatever quiz the people will. What quiz would you like to start with? Low-key 8? Okay, I've got to vote for 8. Does anybody want to do not 8 first? Does anybody not need 8? Like, just not at all, don't care about 8. Okay, so we have stuff on 8 we want to see. Let's start with basics. Are there any basics that anybody wants to see on 8? I'll go nice and slow. Please speak now or forever hold your peace, okay? Yeah, I can, yeah. So let's do the first one where it's literally asking about the slope. So this is 821. So the slope is delta y over delta x. That's the change in the y value over the change in the x value. So let's compare these two coordinates. So we're good, right? Okay. If this goes out of focus or if it's out of frame, just let me know. So delta y is how we're changing in the y direction. So if we start here and go there, our delta y is going to be equal to negative 10. Is everybody on board with that? Negative 10, a change of minus 10. So what would our delta x be if we go from this one to that one? Plus 5. So guess what? There's your slope. If you want to simplify, you can simplify it to negative 2, but I don't care. Ta-da. Okay, cool. Any others you'd like to see out of the basics? Give me an example of one you'd like to see, and I will do it. Yeah. So the easiest way I can think of to graph something is just come up with points that work. Now, you know this is going to be a line, right? So as long as we find two sets of points that work, we win. So what if, like, I don't know, what if y was 0? This would be gone, right? So what does x have to be then? Negative 2. Are you guys seeing that, right? Negative 2 times 2 gets us negative 4. So, yeah, negative 2 zeros on our line. So negative 2x, 0y. Give me another pair of two numbers that would work here. If you're not sure, just pick a random number to plug in for x or something and then see what y needs to be. It might be a fraction, but you can graph that. 0 what? Plug in 0. Okay, we can do that. That means this is gone. What do you times by negative 3 to get negative 4? 4 over 3. The 3's divide out. You keep the negative and you get negative 4. So to graph that, I just go 0 and up 4/3. 1/3, 2/3, 3/3, 4/3. 4/3 is a little bit more than 1, right? That works for me. Like, you don't need to have beautiful points. And then all the other points would just be on that line, right? If you want to find other nice points, you could, but why? We could apply slope here, by the way. Let's use that for finding another nice point. So you know that slope is equal to negative a over b, and we can prove that later if you want. But that means that if a is 2, right? So if a equals 2 and b equals negative 3, then that means our slope is negative 2, right? Do you see how if I negate a, I get my slope? So if I negate a, I get my slope. So slope is going to be negative 2 over negative 3, which is this if you want to simplify. Are we cool with that? That means we can apply delta y, which is plus 2, and delta x, which is plus 3, and find another nice point if we really wanted to. So that's going to get us 2 here and 1 there. Hey, look, 1 and 2 is on our line, right? So you could have done that as well. Or just taken your slope from here and gone up 2 over 3, right? That's the exact same thing. So lots of ways to do it, but you don't need to overcomplicate it. Try and find numbers that work, right? As soon as you get 2, you're good. Any questions about that one? I went kind of fast on that, but it seemed like Grace was the only one that cared. Okay. All right, turning the page. I mean, we can do this. Does anybody want to see either of these two? Yes. All right, so we want to find the midpoint. The midpoint is the average location. So that means we're just going to do this. We're going to add up all our x's and add up all our y's and divide by 2. This is technically midpoint formula. right? The average of our y's, average of our x's. So let's just do that in our heads. 3 and 6 is 9. What's the middle of that? What's 9 divided by 2? 9 abs, right? 5 and negative 3, if we add them up, we get 2, right? So the middle is 1. And look, 1 is 4 away from this and 4 away from that, so that makes sense, right? That's it. That's the midpoint. It's the average location. Bye-bye. You too. Hey, Andy. Questions on that one? Are we feeling okay? Average location, middle, right? Makes sense. Add them up, divide by 2. All right, cool. Find the equation in standard form of the line that goes through this and this. Do we want to see that one or this guy? Yeah, does anyone want the top one? Yeah. All right, check this out. Standard form is this. And I can't remember if it was your class or if it was the other class that we did this one the other day or today. But that's standard form, right? Fun fact. Your slope is always whatever negative a over b is, right? You got to change one of the signs. We kind of talked about that, right? That's the thing. So if we know the slope, we can get this. And if we know one of the points works, then we can get c. That's the idea. So let's do this. Let's find delta y and delta x. Delta y is the change in the y values. So negative 2 going to 1 is a change of what? Plus 3. So delta y is 3. Okay? And delta x is 4 going to negative 2, which is a change of negative 6. You can simplify that or not. It really doesn't matter. That's our slope. So what does that mean? Well, if this is our slope, right? 3. If our slope is 3, what does a have to be? What do you negate to get 3? Negative 3. And b is just literally negative 6, right? It's b is just whatever's on the bottom there, right? So if you want to, you can write it out like this, or you can write it double positive. It really doesn't matter. It'll change what number you get here because it'll be plus or minus, but it's the same idea. So we know this is the line we're looking for. It has this slope, right? Cool. A and b are this. If you change one of the signs, you get back to the slope, right? Cool. So this represents any line with that slope. There are lots of lines with that slope, but we want the ones that go through these points. So how do we know it goes through a point? Well, it works in the equation. Remember we did that earlier when we were graphing, right? So if this is supposed to work here, I can plug that in and figure out what c is. So I'm going to do that. Negative 3 times 4 and negative 6 times negative 2 should get us whatever c is for it to work in the equation. So that's negative 12 plus 12. Hey, guess what? C is supposed to be 0. That's weird, but it's true. That means the equation we're looking for is this. That's the line that has this slope that also goes through these points. If you check, you can plug this in as well. That gets us positive 6 minus 6, right? It also works. Those points are on that line. All right, that was really fast because this is like the 5th time I've taught this today and I need to slow down more. But like, how do we feel about standard form means this? Negative a over b is your slope. So what's the slope? It's this. So negative a over b. Those are the numbers we need. Plug it in. Find c. That one's complex, but once you get it, you're all right. Want to do the bottom one now? This one's easier. Find the equation in standard form. Okay, that's this. Remember, negative a over b equals m. And they told us our slope, so we don't have to go find it this time. Our slope is negative 5. So that means a has to equal 5, and b is going to equal what? Do you know? 1, right? 5 over 1, if you negate the a, gets you this, right? So now we can plug that in, and we've got our equation. 1y is just this. Now, they did give us a point that has to go through, right? 0, 3. Okay, if I plug in 0 and 3, 0 goes away here, right? So what's c going to equal? 3. So here's my equation. 0, 3 works in it, and it definitely has the slope, right? Negative 5, change one of the signs. Okay. How are we feeling? Those are like some of the hardest basics, and they're like hard to wrap your head around. Are we actually feeling good? On God? Okay, okay, okay. Cool. Find the slope, y-intercept, x-intercept of this guy, and then graph it. Want to do it? Do you know what form this is in? Yeah, it's slope-intercept form. Slope-intercept form. This is your slope. It's -3. Y equals mx plus b, right? Okay, cool. The y-intercept. What is a y-intercept? No. No. Yes, it's where your line crosses the y-axis, right? So did you notice that everything on the y-axis has x equals 0? 0, 1, 0, 2, 0, 3, 0, 4. So what we're looking for is 0 something, right? Well, if x is 0, that means y is to be what? So this is your y-intercept. Y equals mx plus b. The b is the y-intercept. That's y. But the x-intercept it doesn't give you for free. We do know all x-intercepts have something in common. They're on the x-axis, right? So that means y is going to be 0. They have no y-ness. They have no height, right? So if y is 0, we got to do some solving. What does x got to be so this whole thing becomes 0? What do you add to 1 to get 0? -1. How do I make that -1? What times -3 gets you -1? 1/3. Do you see how 3's divide out and we get -1? Plus 1 is 0. So we have our x-intercept, we have our y-intercept, we have our slope. Did it, and it says graph it. Well, let's just put these 2 points down and do it, I guess. 0, 1, and 1/3, 0. And then you can make that line. Or if you really want to, we have the slope, right? Down 3/1. I don't know. That's the idea. The key is understanding what a y-intercept is. It has 0 for x. So plug in 0 for x, see what you get. X-intercept, it has 0 for y. So you plug in 0 for y, and you do a little bit of work. Subtract 1, divide by -3. You get them. Slope is free in this form. How are we feeling? Really? Okay, all right. You say so. Some groups go faster than others, but I worry about speed. Is this y equals mx plus b? No. It's standard form. So what's a? 5, right? B is 3. So what is our slope? -a over b. Got it. You see how you just had to change one of them? Right, cool. Delta y over delta x. Change one of them, right? So here's our slope. X-intercept. Standard form is really easy to find x and y-intercepts in. So what do we know about x-intercepts? They're on the x-axis, which means they have no y-ness. So if y is 0, what does x have to be? 4. It is a nice little x-intercept. That's nice. Okay. And we know y-intercepts are on the y-axis. They don't have any x-ness, right? They just go up and down. So if x is 0, what times 3 gets you 20? What's up? 20 over 3. It says nothing about graphing it, so I'm just not going to graph it. But if you wanted to, you could. Here's 3/3, 6/3. You follow me? 9/3, 12/3, 15/3, 18/3. That's 21/3. So back it up a little. It's like here. I don't know. But it doesn't say graph. I just put a graph there because I thought it did, and I'm too lazy to get rid of it. So you know A and B from standard form. That gets you slope for free if you're clever, right? And then you find x and y-intercepts because 0. Cool. Kale, if you want to grab a quiz 8 or anything to follow along, they're over there. That's what we're working on right now. All right. Turning the page. Do we want to see this one? Find the slope-intercept form if it gives you the slope of 3 and x-intercept at -4, 0. Is that a yes? Slope-intercept form is this guy. It's the one where it gives you the slope and the y-intercept, right? So this is the x-intercept, now the y-intercept. But we know our slope. What's our slope? Trace. Very good. So we know this point works. It's on the line. So when x is -4, y has to be 0. So what does b have to be? 12. So our equation is going to be this. Do you see why 12 minus 12 is going to get you 0, right? So that's the idea. Yeah, we're just using what we know to figure out what we don't know. We know the slope, And we know this point's supposed to work. So how do we make this thing work? Well, b has to be 12. Yes? You can, but why would you if it takes this much time? Yeah, I mean, if you want to, I don't care. But you mess it up all the time and it takes more steps. So I wouldn't, but I'm not you. So go ahead and do you. Right. I wouldn't recommend it. Point slope form is literally just slope formula. You know that, right? Isn't that delta y? Isn't that delta x? Right? And if you say this equals slope and you rewrite it by multiplying by the bottom, you get point slope form, which is literally just slope formula. So you have the slope already. I don't know. Like, just seems like a lot. Okay. Intermediate questions. Yes, no, maybe so. What do we want? We're taking requests, guys. You got to speak up. Okay, don't let Grace drive the bus here. Oh, that's cute. 815? Yeah. Here's how you do 815. It's the same thing every time. Do you see how there are no numbers here? I can't change it, so there's no point in putting it on the final. It just becomes a memorization exercise. What is it saying? It's saying absolute value is telling you how far something is from 0. So if I did absolute value of 5, it's 5 away from 0. If I do absolute value of -5, it's 5 away from 0. How does this tell us the distance between x and y? Well, when you subtract, you get distance, right? So that's all that is. It's not worth your time. I put it on there because some people are like, I got that right on the thing. I want to keep it. And I'm like, okay. But it's fine. Don't worry about it. 824. Yep. If you understand what this means, this one's really easy. If you don't understand what it means, it's really hard. All right, graph y equals -3. Can anybody give me some coordinates that work in this equation? That's how you graph stuff, right? So give me some, hey, what's up, Wayne? Give me some coordinates that work with this equation. If x is literally anything, because it doesn't care about x, right? And y is -3, we win. So how about 0, -3? How about 1, -3? How about 2, -3? All of those work with this, right? So let's graph those. 0, -3. 1, -3. 2, -3. 3, -3. What kind of line is this going to create? Don't say a straight line. They're all straight. Try again. Yep, there you go. That's okay. Words are hard. So y equals -3 is a horizontal line. It's all the points that have -3 for y. The y value isn't changing. X is. All right, I'm going to make this next one easier. X is 5.8. Can you give me some coordinates where x is 5.8? 5.8, 1, 2, 3, 4, 5 and change, comma 1. 5.8, comma 0. 5.8, comma 2. 5.8, comma 3. This is a vertical line. We should label it. This is x equals 5.8. All the points where x is 5.8, right? 5.8 for x. Anything else for y. Y can be anything, so it's going to be vertical. Now we want to talk about the slopes. How would you define the slope of this line? It's 0 steepness, right? Slope is 0. No delta y. It's literally just going left and right. What about the slope of this one? It's as steep as possible. It's infinite steepness, undefined. Infinity is not a number. I got you, Wayne. Okay, so if you know what you're doing, it's not so bad, right? Y is -3. So all the points where y is -3. 0, -3. 1, -3. 2, -3. Horizontal, right? And the other one's going to be vertical. Okay, do we want to do 8, 2, 4? Is that what I heard? All right, this, you're overcomplicating. You're overcomplicating it. We're just eyeballing the slope here. So, fam, I'm going to eyeball it. This and this. This is delta y. Is delta y positive or negative, do you think? Well, it depends on perspective. If we're starting here, it's going up, right? So let's start here. Delta y is positive. Here's delta x. If we're starting here, is delta x positive or negative? Positive because it's going to the right. If you started here, it'd be double negative, right? Which is the same thing when you simplify it, but like pick a direction and stick with it. So this is definitely positive slope. Do you think delta y and delta x are equal? I mean, they're close. Which one's bigger if you think they're not equal? Delta x. So can you give me an example of a slope where the delta x is slightly bigger than delta y? And it's positive, right? I'm just estimating. So is 2/3, we want to know, is this greater than 1 or less than 1? Less than 1. That's all. That's it. We're just estimating. If you said it was equal, I'd be like, cool, it's equal to 1. I'm not picky. All right, let's look at this one. Which one's the line? It doesn't matter. It's one, this or this. They both have the same slope, right? So does this have any delta x? It does not. So it's like 0 delta x, literally any delta y. What's anything divided by 0? Undefined. It's vertical slope, right? You know that. Right? We just did in the last one. All right, what about these two? Oh no, which one's the line? Doesn't matter. They have the same slope. What's the slope? 0. All right, pick a point, pick another point, estimate delta y, delta x. So delta y, if we start here, is going to be negative, right? So I'm starting from there. Just pick one and stick with it. If I go to the right, is that a positive or negative direction? Positive. So I'm going to have a negative over a positive. My slope is negative. Do you see how it's negative? Negative slope. Okay, cool. Do you think delta y and delta x are roughly equal? Okay, cool. So it's basically the slope is -1, right? Right? -2/2, -3/3, -4/4. Right? Isn't this like -4, right 4? Right? Yeah. A slope of -1. It's equal amounts, vertical and horizontal. All right, down here, this is pretty steep, right? So delta y is going to be really big and delta x is going to be really small. Let me prove it to you. Here's delta y. Look how big it is. And it's definitely negative if we're starting there, right? It's all a matter of perspective, though. You see how delta x is positive and it's really small? Give me an example of a slope with a big negative number on top and a small positive number on the bottom. -10 over, you could do 2, but that would simplify. That's totally fine. I'm going to do 1 to make it more extreme. But could you do -10 over 2? Yes. Yeah, totally fine, totally fine, totally fine. Okay. So the question becomes, since this isn't equal to 1, it's not undefined, it's not 0, is our slope, since it's negative, is it greater than -1 or less than -1? What would you say? It's less than, because -10 is a smaller number than -1. That's what gets everybody. That's what gets everybody, right? -10's further to the left in the number line than -1. So that's what they want to know, because you just made that up, right? So it's definitely less than -1. It's really negative, right? Here, how would you describe this slope? It's very positive vertical. Because we're going to the right and up if this is our perspective. So somebody give me an example of a really vertical slope. Yep. So is our slope greater than 1 or less than 1? Greater than. If it's positive, you compare it to 1. If it's negative, you compare it to -1. If it's 0, just write it's 0. If it's literally -1, just write it's literally -1, right? If it's undefined, just write undefined. But it's these guys where you're like, it's kind of a little weird, where you're going to have to compare it to -1 or +1. That's it. That's it. It's all a matter of eyeballing it. And it gets everybody tripped up because it's trippy. Are we feeling better? Better is the key. Depending on what you did during the semester, you're going to feel a lot better or you're going to feel a little bit better, right? It just depends. Cool. All right, I'm not doing 831. We did it in class today. I've recorded it multiple times. Sorry, not happening. Boo, watch another video. I'm tired of doing it. All right, what about 833? Does anybody want to see that? Yes? First, it says find the midpoint. Guys, how do we find the midpoint? Nope. What is the midpoint? The average location. How do you average? Add them and divide by 2. It's not half distance, right? It's half the location. Distance is subtraction, right? But location, we just take them up and average them, right? So 3 and 6 makes 9. Hey, look, it's 9 halves again. 5 and negative 3 is 2. Hey, look, it's 1 again. It's the same points from earlier. That's the middle, right? Now, words are hard here. Words are hard. It's saying we want to find a point where Q is the middle of PT. So here's PT, okay? And they said Q's the middle. Okay, well, we know what P and Q are. They gave it to us. P is 3, 5. Q is 6, negative 3. And what we want to find is, what does this need to be? So Q's the middle. Well, if we're going from 3 to 6 in the x direction, this must be 9. There's a complicated way of doing this, but why would you do it? If we're on 5 and we're going down 3, or down to negative 3, we went down 8, right? So now we're at negative 11. That's going to put this in the middle, right? Minus 8, minus 8. It's 8 away from both. Do you see how this makes this in the middle of 5 and negative 11? They're both 8 away, right? Do you see how this puts 6 right in the middle of 3 and 9, right? Yeah, it's that easy. All right, we love standard form, so I think we should do 843. Find the equation in standard form. Oh, yay, standard form. And we know the slope is a third. Oh, that's so nice of them. So the slope is going to equal negative a over b. That means a has to equal what? What do you negate to get 1? Negative 1. And what do you plug in for b to get 3? You plug in 3 to get 3. So this is our equation. Now that represents all the lines with that slope, right? There's lots of lines, infinite lines, but we want the one that goes through 3, 7. So how do we make sure this goes through 3, 7? You plug it in and make sure C works with it. We did this earlier before you guys got here. That's why we're going kind of fast. I apologize. So, gentlemen who got here, standard form is this. Fun fact, your slope is always equal to negative a over b. This is just life. We're going to prove that later in a spicier question. So if we know the slope is a third, and we know it equals negative a over b, a has to be negative 1, so when we negate it, we get 1, right? And b has to be 3. Oh, look, a is negative 1. Oh, look, b is 3. And all we're going to do is we're going to plug in the point they gave us to figure out what c equals. And then we're done. So we plug in 3, we plug in 7. We're getting negative 3 plus 21. So what is c going to be? 18. So make sure you write the actual equation. It's going to be this. I want all the points for x and y that give me 18, right? That's it. That's one of the hardest ones. Like any of the standard form ones are like kind of the hardest ones. So if you're feeling a little that's why. Okay, now what? No sound, but now. Next one. Grace, speak for yourself. Everybody's at a different spot. All right, does anyone want to see 855? All right. Prove that this is true. Prove that the slope is equal to negative a over b. Where did that come from, right? Why do we know that's true? Here's why. Remember this guy from earlier? Yes? This is slope-intercept form. What does M stand for? Montere, which is slope. Thank you. So this is saying if we get y on its own, whatever's next to x is a slope, right? I'm going to prove that when I get y on its own from this, I'm going to end up with this next to x. I'm going to prove that this is going to appear right there. Okay? So how do I get y on its own? What do I need to do? Yep. Now, pause. This is kind of weird. I'm minusing ax over. I'm going to write that first just so it's in front. See how there was already a positive c there? Are we okay with that? C minus ax is the same thing as negative ax plus c. Cool. And then when I divide it by b, like Aubrey said, look what happens. Look what's next to x. Negative a over b. That must be the slope. I've proven it. Also, it turns out your y-intercept is always c over b, but like that's just another formula. Why would you do that? Just focus on this. We've proven it. That's slope. Did you notice there are no numbers in this problem? I can't change it. It's the same every time. Okay. Feeling okay? Okay. I don't care. We've done it enough time. Mr. McFalls is tired of it. 861. Do we want to do it or no? Okay. This one's kind of weird if you don't know what you're talking about. So let's talk about what makes something perpendicular. Let's do it by doing this. Hi, Tiny. Position 1. Oh, good, it's there. All right, so let's talk about what makes something perpendicular. You guys know what perpendicular means? 90 degrees. Yes. So I'm going to sketch a 90-degree angle, and I'm going to give you some intuition. This is not a proof. This is intuition. Intuition is good. I need black markers. I moved it today. All right. So when something is perpendicular, like, I don't know, this, maybe it's a 90-degree angle, so says me. Let's talk about the slope of these lines. So this is delta y, and this is delta x. I'm just going to do that, okay? Is that okay? Delta x and delta y are both negative here, it looks like to me. If you go from top down, right? They're both negative. Now, what happens with this line? Do you see that I can take this line and rotate it? And this will rotate 90 degrees. So this part right here, I'm going to do it in red now, okay? This part right here just moves to there, right? So this is still whatever that value was, but of course this is a delta x now of the other line. Do you see how it's the same number as this? It just, now it's the delta x, and it changed that it's positive now. See how this rotates as well? So this is the same number as this, but now it's negative delta y. So in other words, it's this, okay? Let's pretend this was like negative 3 and this was negative 2. Do you see how when I rotate this, it's now positive 3, and this part right here is going to be still negative 2? So what happened? The original slope, the one down here, was negative 3 over negative 2, right? Yes? The original slope is negative 3 over negative 2. The new slope, the one that's perpendicular to it, is now delta y is negative 2, and delta x is 3. So what's the relationship? Opposite reciprocals, yeah. Do you see how it's reciprocated and negated, right? Yeah, there's a lot of negatives here, but those divide out. Is that better, right? Opposite reciprocal. So it turns out, to make perpendicular slope, all you have to do is take your original slope and do this to it. Opposite reciprocal. I use this symbol for that because they're not equal, right? This symbol, opposite reciprocal, negative sign, flip it. So that's the idea. Are you ready? Are you ready? Okay, we're going to take a second to like do all this because I don't know how to get rid of it. Luckily the sound isn't working because it would be every meme all at once. I want a line that's perpendicular to this. Isn't this kind of the slope of that line? So wouldn't opposite reciprocal be this? Right? Isn't it the slope flipped and negated? I know, like, to get the actual slope, you have to negate this, but, like, the idea is you switch them and change one of the signs, right? So this is the line we're looking for, right? This is line L that's perpendicular to this guy. And it says it has the same x-intercept as the original. So what's the x-int for this line? What do all x-intercepts have in common? 0 y-ness. You're on the x-axis, right? So if y is 0, what times 3 gets you 5? If y is 0, what times 3 gets you 5? Try again. 2 times 3 is not 5. It's 5/3. Because 3's divide out and you get 5. It's okay. It's okay. We're not adding. So this line has the same x-intercept as this. So doesn't 5/3 work in this equation? Okay, cool. So plug in 0. Gone. What's negative 2 times 5/3? Negative 10/3. Hey, look, that's the line we want. A pickier math teacher would say, And an even pickier math teacher would say, leading coefficient can't be negative. But I am not he. You can circle this, this, or this. Oh, why is it curly? Stop, stop, stop. Go away. Go away. All right. Billy believes in ghosts. Do not scare her. She will die. Don't do it. I'm here all the time late at night. I have to, like, announce my presence. Like, I am here. This is not someone calling from the dead. She's very, very superstitious. And if you were here this late at night, you would, like, all the time, you would be too. One time I was at a school, Newark, the first school I taught math at, and they had this thing called the hole, which is like what we have, the basement or whatever, except it's way darker. And on certain nights, you can hear Oklahoma coming out of it, like the musical. There was one time my mom was there really late because she's a guidance counselor, and she heard an entire basketball game taking place at 1 in the morning in the gym with, like, buzzers and stuff. And then she went in there, and there was nothing, and the sound immediately stopped. Crazy, huh? Yeah. All right, anyway. Yeah, I didn't like staying late at that place, but I did it anyway because I love my students. Okay. How are we feeling about this? Perpendicular. Oh, my gosh, right? That's super easy. And then you just plug in the thing and see what happens? Okay. Want to do this one? This one's really easy, too. It says parallel. What does parallel mean? Yes. I'm seeing this. Yes. Same slope, right? If they're the same slope, they'll go at the same angle, right? So if this guy's slope, or let's get it in standard form. Right? This is the original. Won't our equation that we want look like this? It's parallel. So this will be the same. But wait, it's got to work with 3, 7. This one won't work with 3, 7, but this one has to. What happens when we plug in 3 and 7? 3 minus 21. That's the line we need. Are there other ways of doing this? I will admit that there are. But why would you? If you know what it means, it's super easy. It's super easy. Same slope means these will be identical, right? It's just this has to be different, so 3 and 7 work. All right, how do we feel about that? Better? I could have gone slower, I suppose, but it's really easy if you see it, right? These will be the same if they're parallel, because same slope. No, because if it was the same number, they'd be literally the same line. We want it parallel and going through this point. This one does not work. 3 minus 21 is not 8, right? So this is not on that line. But they are parallel. Same slope. Yeah, good question. All right. Hey, we're on to spicy stuff. No. Unless you've been waiting for spicy. If everybody's like, I'm here for intermediates, let's just call it a day at that. Unless you're like, no, I already got all those. I've been waiting. Is anybody like, I've got all those. I wanted spicy? Yes, it is there, but your grade can't go down unless you tried the spicy earlier and now you're like, oh, I can't do it without my notes. You didn't try it earlier, so your grade won't go down. That's fine. You did? You don't have to do them. Here's why. I know it's kind of loosey-goosey, but I promise I have your best interest in heart. I am not going to just ruin you just for fun, okay? That's not what this is about. Why do I push you during the semester? So you can get better. There's no point to be like, at the end, because you're not going to be able to improve, right? Now I am 100% just like, yeah, they got it, who cares? I'm really lenient on the final, right? So, Grace, if I have enough evidence from all the other things you've done, and I do, that you know how to do those, even if you don't get to it in the final, it'll be fine. It will be okay. The real danger is if you're one of those people that was constantly just copying down stuff, writing down random numbers from the old notes, copying things you don't understand, and now you can't do anything on the final, that's going to be like, I don't think you really understood those things. It very rarely happens. Very rarely happens. I think you'll be okay. I don't think anybody in here is in danger of that. Whatever you know is what you know. You'll be all right. So that was 8. Unless anybody wants to go back and look at any of some of these, are we okay? Wayne's like super chill. Either that or he's furious. I can never read him. I don't know. A raging volcano. He's always mad. That's right. Raging volcano. All right. God, Wayne. Eat a Chewy bar. Who wants Chewy bars? Chewy bars. And Rice Krispie treats. Oh my God. One starburst for you. 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 All right, does anybody want things from quiz 4, 5, 10, or 11? 10? Is everybody saying 10? Okay. I just don't want to like leave anybody out. All right, 10 is the one with the 3 on it, because like, duh. I've been over the story a million times. So I'm going to just hit all of the milds on 10, because there aren't that many. It's pretty easy. Hey, what if I times by 3 to get rid of division, because it's an equation? Doesn't that make your life easier? Does anybody know what you times by itself to get 900? Try again. 30 and negative 30. You were... See how 30 already has one of the zeros? So 30 times 30 is going to get you 9 with 2 zeros, right? And then negatives times negative is a positive, so we're good. All right, these first 2 are the hardest because they're not like anything else we do. They're like the basic intuition, and it's so far away. So that's why. Are you okay? Okay. So this one right here, I'm gonna show you how to do it, and then I'm gonna show you how to make sense of it. Okay? So if I put everything on the same side, I make it equal 0, right? That's a good idea. How do we factor this? This one's easy because it doesn't have a constant. What common factor do they both share? R. So I can factor out an R, and I get this. So when will this equal 0? When R is negative 18, right? And when R is what? How do I make that part 0? You just plug in 0. You see how 0 times 0 plus 18 is 0? Do you see how 0 times negative 18 is 0? All right, now, I'm going to make sense, okay? Check this out. What number times itself is the same as negative 18 times it? Negative 18. Isn't negative 18 times negative 18 equal to negative 18 times negative 18? Stop telling me it's positive 18. Positive 18 times positive 18 does not equal negative 18 times positive 18. Isn't 0 times anything equal 0 times 0? I'm going to change the number, and it's going to be 19. It'll be 19 and 0. This is the hardest class anyone's ever taken. All right. Does anyone want to see? Oh, yeah. We said we want to see 10-1-3. Read directions. I'm going to show you it once, and then I'm going to cross it out because we can move on. Okay? Find all the values where it equals 0. All right. Let's find the hardest one. It's this one. When will this equal 0? Give me one of the numbers where x is going to make it equal 0. Do you see we plug in 2 over 5 here and here? We plug in 2 over 5 here, we get some number, right? But what do we get here? 0 times anything is 0, we win. What's the other number I could plug in to make this whole thing 0? -5. I plug in -5 here, I get some number, but here I get 0. 0 times anything is 0. Those are the answers. But I also need you to expand the product. What does that mean? Distribute, get more terms, right? X times X is what? Not 2X. Do not say 2X. Thank you. What about X times 5? -2/5 X, right? We're going to get commie denomies in a second. This one's the hardest one. Now, what about this? The 5s divide out, don't they? And we just get -2. That's nice. Let's get common denominators. If I times by 5 over 5, that does not change the problem. That's 25/5 now, right? What's 25/5 minus 2/5? 25/5, take away 2/5, 23/5 X minus 2. Great question. First off, is this an equation? So we can't multiply to get rid of denominators. Second, what is 5 over 5? So does timesing by 1 need to be done to everything? No, it's timesing by 1. It didn't do anything. It just made it look different. That's the magic. That's why I like do that every single time. It's super important. Turns out the next thing we're going to learn is that if you add 5 and then subtract 5, that's legal. Because what is adding 5 and subtracting 5? It's just adding 0. Turns out that's really important for what we're about to do in second semester. Like, how do we add 0 but make it weird, right? All right. That's how you do all these. Distribute, tell me the answers. Yes? Okay. By the way, what are these called? Conjugates, thank you. It's going to be a difference of squares, x squared minus 16, right? Middles are going to go away. All right, 100 times my number. That means this, right? Is equal to the square of my number divided by 4. What possible answers could my number be, right? Well, let's make this easier to work with. How are we going to make it easier to work with? Yeah, it's an equation. You can do that. If this were not an equation, you could not times everything by 4. That would change the problem because it would make everything 4 times bigger, right? But since it's 4 times bigger on both sides, it's still equal. It's okay. Fam, I want you to use your brain. 400 times something equals something times something. 400. Isn't 400 times 400 going to equal 400 squared? What's the other number? It's not -400. It's 0. Do you see how -400 times 400 is not -400 times -400, right? So it's 0. 0 times 0 is 0 times anything. It's the same thing we did for the second question. It's just we didn't move it over in factor. Okay, those are like some of the hardest ones. Do we want to see 10-1-5? Okay. Basically, oh God. Basically what's happening is this. Instead of giving you this and asking for the answers, 7 and -2, right? It's giving you the answers and asking for the question. Write the product of 2 binomials. Okay, imagine there's 2 things there, right? That's a binomial. Imagine there's 2 things here. That's a binomial. This is the product of 2 binomials. Is equal to 0 if we know x equals 3 and x equals -5. Fam, if these are the answers, what are the questions? Turns out that's super important pre-calc. Super important. I don't know. That's it. I'll change the numbers to 7 and -4. This class is impossible. All right. All these, let's do them. So, see how we have a constant here? We can't just take out an r from everything like we did in the first page. So that's why we're going to do this thing, the thing that you guys remember the most, the thing that you really remember from chapter 10, right? So we need r and r to get r squared, right? Right, we all on the same page there? Right, distribute, get r times r. Now, notice we're also going to distribute here, and that's going to get us a certain amount of r's, right? And then here's going to get us another bit of r's. That's going to have to add to the total amount of r's. And then what have we put here? Do you see how this and this don't have r's? That's going to multiply to something without r's. So whatever goes here multiplies to 18. There's not a lot of ways to do that. Can anybody think of what needs to happen here? Yes, you have an idea? 3 and 6 is what we need. Notice that 3 and 6 gets you multiplying to 18, but do they add to negative 9? So they need to be double negative. Yeah, if you know that's positive, we're either dealing with double negative or double positive, right? So that they multiply to a positive. But we wanted double negatives. Now, here's the thing everybody really forgets. Did we solve this problem? Do we know when r makes this equal 0? Not yet, but we're going to say it. It's 3 and 6, right? You have to answer the question. I don't know. Maybe I'm just different. Okay, down here, let's move everything over so it equals 0. Finding out when things equal 0 is easy. T and T, dynamite. These two numbers have to multiply to a negative. So what does that tell us? Yep, one of each. It doesn't matter where you put them. They're symmetrical, right? Can you think of any numbers that multiply to 14 and then they'll add to 5? Well, let me say it again. They multiply to negative 14, add negative 5. Negative 7 and positive 2 gets you negative 5, doesn't it? The goal is to take out all the guessing as much as possible. I know it has to be one of each. I know it has to be T and T, right? I'll start thinking about 14. There's not that many ways to do it. That way when you start running through the combos, it's not too many. We're not done. T is negative 2, T is 7. Those are the two ways to make this whole thing equal 0. It's the most wonderful time. Did we do this one in your, and wait, is everybody third hour? No. Are we all fourth hour? Okay, I don't remember. I'm going to be honest. It all blends. Okay, so somebody, one of the classes at least did this one today, and this one's kind of devious. What's Camden's class? Is it third? Fourth? See, I have no idea. This one's kind of devious. First of all, make it equal 0, because multiplying to 0 is easy, right? That's kind of the idea. Timesing to 0, it makes it easy. So if it is factorable, and eventually we'll be able to factor anything, but that's not until chapter 13. Yeah, I think it's 13. What do we know? Let's eliminate some of the possibilities here. What do we know about these two numbers? They got to do what? It's got to be a double negative, because two negatives multiply to a positive, right? And they'll add to a negative. All right, now we need numbers that multiply to 144 that add to 25. There's a lot of them. When in doubt, make a little chart and make sure you don't miss any of the factors. It definitely is. No, that does not get you 25, right? That's negative 145, right? Cool, yeah, so that's not it. But we're going to go in order, just make sure we don't miss any. 72, oh, darn, negative 74, not quite. 3 goes into it, but we need higher numbers than that, right? It's got to be bigger. So Aubrey said 12 times 12. That gets you 24. Oh, that's so close. Maybe it's impossible. Check this out. This is what you know, right? It is 9 times 16. Do you see it? That's 25. Isn't it weird that 9 times 16 is 144? That's freaking weird, but it's so true. It's so true. I always forget about that one. So x is 9 and x is 16. I skipped all the other ones because, like, 3 times something is still going to be way too far away from 25, right? So I might as well just skip it. This one down here is kind of annoying. Technically, it's unfactorable, but at the same time, just use your brain. So, fam, this. What's underneath my pencil? Don't say y squared. What is it? It's 200. So what do you know? Right? There's no nice number you times by itself to get 200. It's just this. I don't know. I mean, technically not factorable, but like at the same time, like how hard could it be? If this were 16, we'd put plus or minus 4, right? Yeah. Okay, how do we feel? Honestly? All right. We should do this. Mondays, Tuesdays. In fact, we should do it Monday through Friday, 5 days a week for 16 weeks. 42 minutes a day, third or fourth hour. This is good. Think how much we'd learn. We could call it school. It would never work. It would never work. It would never work. You don't lock in. All right, this one. I know what you're gonna do, McFalls. You're gonna be like, okay, I need the sum of the roots, so I'm gonna factor it, and I'm gonna add up the answers. Okay, and I need the product of the roots, so I'm gonna factor it, and when I get the answers, I'm gonna times them, and it's gonna take you 10 years, right? Fun fact, did you know the sum of the answers? Like the answers we found on the last page, like these guys, right? The sum is 9, the product is 18. Did you know you can find those like for free? The sum of the roots is always this. The sum is always gonna be negative b over a. Always, always, always. If it's in standard form. This is a different kind of standard form. This is quadratic standard form. So what's negative b? What's b negated? Yeah. And the a value is 1, right? So yes. I can prove why this is to you, but no one cares. But I can prove it. Did you know the product will always be C over A? What's C? Negative 324. And A is 1, so guess what? Apparently, the answers add to negative 15 and multiply to negative 324. Would you like me to prove this so you know why this is true? You can say no. Okay, fair enough. What is this? McFalls. Thank God. What do difference of squares always have to factor to? That way the middle goes away. So we need x and x. I mean, even before you knew this was chapter 11, right? Even before you knew difference of squares, you can factor this, just use your brain. We definitely need b and b, but b's negative. Oh, look, and the middle goes away. Okay, yeah, it works. Okay. These ones, depending on the quiz, because dumb stuff, these are technically intermediate, but you want to do them anyway? Okay, cool. Why is it intermediate? Because A isn't 1. This gives us options. So it's either going to be 10x and x. What's another way to get 10? 5 and 2, right? Now, the goal is to eliminate guessing, okay? What do we know for sure? What do we know for sure? It's got to be 1 and 1, right? Is it going to be double positive or double negative? Double negative. Which one of these is going to get you negative 11? The top one, because remember, this hits it first. And we get negative 10x's and negative 1x to make negative 11x's. So it's not the bottom one, it's the top one. So what are our answers? One of our answers is when x equals 1. Bam. What's underneath my finger? Don't say 10x. Try again. Positive 1. 1 minus 1 is 0. What times 10 gets you 1? 1/10. 10's divide out, you get 1 minus 1, 0. All right, let's make this one equal 0. Ooh, 11, that sounds scary. It's actually not. 11's really great because it's prime. There's only one way to multiply to 11, right? 11r and 11r. Or sorry, 1r, I mean. So that's locked in. That's good. We know we need numbers multiply to 4. Are they going to be double positive or double negative? Yeah, that way they can add to a negative, right? Two positives will never add to a negative. So it's got to be double negative. They'll multiply to a positive, and they'll combine to a negative. It's either 4 and 1 or 2 and 2. Where do we want to put the 4? If we put it over here, we get 44, negative 44r. And then we get minus 1r. That's negative 45 r's. We want it here, so it's away from the 11. Check this out. If we put the 1 here, we get 1 times 11, which is what? 11r, right? Negative 11r. And then this just becomes negative 4r's, which is how many r's? Negative 15r's. So whatever you put here is going to get hit by this before it adds together. Before we didn't think about that because we didn't have any number in front of it, right? So that's negative 11r's, that's negative 4r's. These will still just multiply to 4, right? That's no big deal. They're not be affected by this, right? But you have to think, that's going to hit this guy, right? What do I want to get hit by 11? Probably not something too big. Probably 1. 2 would be 22. Maybe it'd work, but eh. So now let's do our answers. One of the answers is 1. The other answer is what? 11. What? 4 11s is correct. I was wrong. 11s divide out, we get 4 minus 4 is 0. Ooh. Is it possible? Well, first, like, make it equal 0, right? Move things around. Please, for the love of God, do that. Stop trying to hard mode everything. I don't know what's wrong with you people. Okay, good news about 3. It's prime, right? So we know it's got to be 3v and v if it works. What else do we know for sure? It's got to be a negative and a positive because they got to multiply to a negative. Well, 2 negatives multiply to a negative? Not without imaginary numbers, right? So we need a positive and a negative to multiply to a negative 24. Now, if I had to guess, we probably want the positive here and the negative there. Here's why. Do you see how the 3 is going to hit this and triple it? I want a really big positive number, not a really big negative number. Am I right? I don't know. I'm just trying to set up a really good guess. All right, multiples of 24. Well, if I use 24 and 1 and put a 24 here, that's going to be huge. Minus 1 does not give me that. 24 here and 1 there, that's negative 24 plus 3. No. So it's not 24 and 1. Is it 2 and 12? 36. That's pretty close, right? Are you seeing it? 36 minus 2? You gotta think. The further you get in math, the more you just have to. It's just a fact. So this worked, actually. V is going to be negative 12. What's the other answer? 2 over 3. 3's divide out, and you get 2 minus 2. I'm making it look easy because I have lots of experience, right? But it boils down to take out as much guessing as possible. Got to be one of each. Got to be 3v and v. Try to think about what makes sense by getting this. The right big positive number, right? Bad news. There's multiple options for 15x squared, right? This will be 16x's when I add that over. Yes, we are adding that over to get 0. I'd love to divide everything by 5 or 3 to make this simpler, but it doesn't work, so I'm just going to leave it. Our options are going to be 5x and 3x or 15x and 1. Now, here's the thing. If this was 15, isn't it going to times something by 15? That's going to make something really big probably. Is 16 really big compared to 15? No, it's not, right? So if I did 15 here and 1, 15 times something is going to be a lot bigger than 16. Probably, right? Probably. So this is probably my best guess. So I'm going to start there. What else do I know? If one of each, then it'll multiply to a negative. It's got to be double positive so that it multiplies to a positive and adds to a positive. Guys, how many different ways can you multiply to 4? Not many, right? So, what do you think? Do we want 2 and 2, 4 and 1? What do we want? Why 2 and 2? Ten of them, 6 of them. We win. There are 2 answers. First one's negative 2/3. What's the other one? Negative 2/5. Because you need negative 2 plus 2 to get 0, right? Yep, it's -2, but we got to put it over 5. It's -2, but we got to put it over 3, right? Hawaii. Hey, guess what? We're on the intermediates. So now we're playing the game of Who Wants an A? Because if you've gotten up to the intermediates, you've gotten a C guaranteed, assuming you did the homework. And because everybody did the homework, we now all have C's. Isn't that great, Wayne? If you guys do what I ask you to do, this is a much easier class with less stress and less work. The homework is basically free. I give you the answer key. If you do one of the problems and don't do the rest, I'm like, oh, good, rough draft. 100%. Anything you get right on the homework with the answer key counts as one piece of evidence. You need 2, Wayne. That means you take the quiz once and you're fine. Or we could just take the quiz like every day in homeroom forever. And then your parents are like, why does he make you do this? And I'm like, I don't make them do this. What I should do is what other teachers do, is make you prove you know what you're doing on like a separate assignment before you can retake the quiz. And then I wouldn't have 5 billion people in here. But you know how annoying that would be? That'd be really annoying. You guys would hate me even more. So I don't do that. So I just punish myself. All right, you want to see 10-1-6? Okay, fam, stop making this harder than it is. If I gave you this, wouldn't you distribute? Okay, so what if we do that and then times that by this? It asks another thing. Did you read? You didn't read. Expand the product. Okay, cool, it wants this times. When does it equal 0? Isn't it obvious when it equals 0 right now? Can somebody give me one of the answers? Thank you. 2, what's the other answer? And -3. Stop forgetting to do that. Read. All right, now we're going to distribute. I'll do these 2 first because, like, I don't know, why not? We're on X game mode. I'm going to go a little faster this time. X times X is X squared. I'm going to get -5X's. But wait, there's more. I'm also going to get -2X's. So how many X's? Thank you. I'm cutting to the chase here. And -2 times 5 is +10. We still have to times all that by X plus 3. Do you know how to do that really quickly? You times everything by X. That's super easy. And then you go back and times everything by 3. That's easy. Timesing everything by X, I get X cubed -7X squared plus 10X. Do you see how I times everything by X? That's crazy. It's crazy. It's crazy. What if I times everything by 3 now? Then I get plus 3xy, or sorry, X squared. I get -21x's, and I get plus 30. I'm going to simplify just because I'm like that. These can go together. How many x squareds will I have? Thank you. X squareds. These can go together. How many x's will I have? Hey, look. 30 doesn't have a partner, just like you at the dance. Hey, look, x cubed doesn't have a partner. Incredible. We have done it. We have done it. This is how you get an A. This is what it takes. It's no. Wayne and I, we're bros. Wayne taught me everything I know. Wayne is the blueprint. Let's rearrange this. So that's in order from highest power to lowest power. That's a 54, my bad. Gee, I sure hope it was divisible by 3 everywhere. It's divisible by 3 everywhere. We can, and it's an equation, so you can do that to every term. X squared. Don't you know 6 times 9 is 54? So isn't that 3 times 2 times 9? It's 3 times 18. He's doing the finger thing. Nobody knows how the finger thing works, but everybody does it. Yeah, 6 times 9 is 54. So we can rewrite that as 3 times 18, right? So this is 18 after you divide it by 3. Isn't 243 just 240 plus 3? Isn't that 80 and 1? It's 81. Long division is for losers. If you were spending 20 hours a night doing long division, or this instead of long division, like you did long division when you were like in whatever grade, you would be so good at this now. But we didn't. We did long division, and it's useless. All right. This is pretty easy. Doesn't this look like a basic problem? Did you know all intermediate problems are basic problems in disguise? You just have to know how to get it there. X and X. Do we need double positive or double negative? It's 9 and 9, but is that the answer? You would not believe the number of people, Eli Perez, that do not tell me the answer for these. I don't care if you write it once or twice. There you go. I wrote it twice. I was feeling festive. Festive. I keep everything. When I die, my entire basement is bequeathed to all of you. Good luck. I really am a big fan. All right. Oh no! Or even better. 2. Could you do 10? Yes. And then you'd go, oh, I can divide everything by 5, right? But like, let's just times by 2. That's simpler. What are you doing here? Okay. Oh no! It has to be 2 TNT. Dynamite. What else do we know? What else do we know? It has to be double negative. Aubrey and friend. 2 negatives multiply to a positive, and they'll add to a negative. Yes? So we see that? Awesome. I just want to make sure. There are a lot of ways to multiply to 7. It's 7 and 1. Where do we want the 7? Not here. That way it doesn't get hit by the 2. That becomes -2. That becomes -7. Hey, that's -9. Hey, look, I really wish that was 7, but we gotta divide it by 2, I suppose. I love how, like, this part right here is, like, the entire course of Algebra 1. Like, just this right there. And we're doing it in 5 seconds. Not even, like, half a second in our head now. But good for you guys. All right, are we ready to turn the page? All right. The sum of the roots is -3. And the product is -40. Don't the sum of the roots always equal -b over a? This is not the same thing as slope. I know it's like super similar to -a over b. This is not standard form of a linear equation. Okay, so that means b had to be what? Right? Doesn't b have to be 3 and a have to be 1? Isn't the product always c over a? So if a is 1, we already said that. What's c got to be? Hello? Hello? -40. So our quadratic is going to be ax squared. A is 1. Okay? I have to prove to you why this is true. Do you want me to do that? Okay, I will do that next. In fact, it might be coming up. Anyway, ax squared, so 1x squared. It's bx, so 3x, and minus c. There's our quadratic. Now solve. Let's find the roots. I'm even going to do it up here because I'm like a baddie or whatever. Isn't that a thing? I think it's a thing. All right. Look at this. I'm going to do my work on part B for part A. What do we know? What do we know? Aubrey and friend, what do we know? What do we know about these two numbers? 2 negatives will never multiply to a negative. It's got to be plus and minus. It's okay. We're going to get there. We're going to get there. We're going to get there. All right, so we need numbers to multiply to 40, and then when they add, one's going to be minus, right? So it's kind of like they're subtracting to 3. Can you think of any numbers that multiply to 40 that are separated by 3? Because one of them is going to subtract, right? What 2 numbers are separated by 3 and multiply to 40? 8 and 5. Wayne, do we want positive 8 or negative 8? Wayne taught me everything I know. This is a test. It's not -8 because -8 plus 5 would come out to -3. Wayne taught me well. 8 minus 3 is, sorry, 8 minus 5. God, I'll never be as good as Wayne. 8 minus 5 is 3. But it also multiplies -40. I become so now. X is 5. I'm standing in the shadow, trying to be who you want me to be. I sing that in the shower every morning. And I think, Wayne, I'm never going to be good enough. I'll never live up to you. All right, X is -8, X is 5. Are we happy? Hey, look, it's intermediate problems. We times everything by 9. We divide everything by 3. 4 doesn't go into 45 or 42. Oh. Thank you, Wayne. Thank you. It's my channel. I can do what I want. Like and subscribe. All right. Do you want to see these, or are we just going to be like, times everything by 9, do it. Divide everything by 3, do it. Is that okay? Okay, cool. Okay. Mr. McFalls. We want to know when this equals 0. But there ain't no numbers. The first one is -b over a. Are you seeing it? Because what'll happen? A's divide out, we get -b plus b is 0, right? Can someone tell me the answer to this one? We want it to be minus d, right? But it's over c, so the c's divide out. Yes. It's always that pattern. It's just trying to get you to recognize that. We've been using it for a while now, right? Speaking of patterns. Oh, they on their phones. Speaking of patterns. They said this factors to this. So if we know that, what will this factor to? What do you notice about these two? Yeah. So it'll factor the same way, except what? It'll still need 6x and 2x. It'll still need 7 and 15. But it's going to be double negative. That way it multiplies to two negative numbers and they add to this, multiplies to a positive. So that's how it would factor. A lot of you guys were like trying to brute force factor it, or you'd tell me the answer to this one. Words are hard. All right, Aubrey's friend. What is this going to be? What do we need? That's not Aubrey's friend. You're not Aubrey's friend. Aubrey doesn't know you. 7 over 6. Thank you, Aubrey's friend. We're trying not to use real names here because this is going to be public on YouTube, and I want to keep my job. So we're just going to be Aubrey's friend. That's going to be Koa. That's code name for Koa, so we don't say her name on the stream. Okay? That'll keep her information secret. 15, right? Oh no, it's not 15. It's 50. It's 15 over 2 because the 2's have to divide out. These are how you get an A. These are real doozies. These are the ones that take like all year. You gotta like come in all the time. You gotta like Okay, moving on. Find the sum. I know what we'll do. We'll factor this. No, why? No. The sum is negative b over a. It's negative 84 over negative 32. Don't even simplify. No one said you had to. Why would you try and factor that? Why? There's a million options for negative 32. Read the directions. The sum is negative b over a, so it's this. And Koa's like, I don't believe you, and I'm going to prove it soon. I mean, Aubrey's friend. Okay. All right, time to factor this so we can add them to, no. Find the product. Over a. Which means it's negative 500 over 18. I need to take the quiz 12 times to get that one right. At least 100. Okay, we good? Turning the page. I did this one in one of the classes. Does anyone want to see this one? Is that a yes? What do you think? All right, here's the logic. I want to know what k cannot be if x is an actual number. It can't be 6. Do you know why k can't be 6? I will explain. Imagine k is 6. What is x minus 6 over x minus 6? It's 1. Will this ever equal 1? No, because the tops will always be 1 apart, right? So there's no number for x you could plug in to make this equal 1, and this would have to equal 1 if k was 6, right? So that's the one you get for free. And then the normal strat for your friends is to like just make up another number that k can't be, like 7, and then just hope. Don't do that. Fam, I'm gonna do it. I'm gonna do it. I'm gonna cross multiply. Now, you don't need to ever cross multiply. Do you know why I'm gonna times this side by x minus 6? Because it gets rid of that. Don't I have to do it to both sides? Do you know why I'm going to times this by x minus 2? To get rid of that. Don't I have to do it to both sides? That's all cross multiplication is. Why am I doing it? Because it's an equation. I want to move things around. You don't need a special name for that. That's called solving an equation. So what are we going to end up with? We're going to times x minus 6 to both sides. And we're going to times x minus 2 to both sides. When we times by x minus 2, this divides out, but it doesn't divide out here, right? When we times by x minus 6, it'll divide out, but it won't divide out here? That's all I'm doing. I mean, if you want to... Here. Oh, fine. I won't do it. I won't do it. I'm just multiplying. I'm not cross-multiplying anymore. Right? I'm just timesing to get rid of the bottom. Why? Because it makes things easier. Let's distribute. Because the goal of this is actually to get x on its own. All right. Are you smelling what the rock is cooking? I'm bald now. None of you know him from his wrestling days. All you know him is from Jungle Cruise or whatever that was. You're all posers. You're not real fans. Rey Mysterio for life, right? These subtract away, don't they? If I subtract from both sides. Are we seeing how I got this, by the way? -1, -6, -7, right? Positive 6. X squared, -2x, -kx, positive 2k, right? The goal is to get everything with x on one side. But what if it has x and k? Did I stutter? Everything with x on one side. Is this x? Then it's got to go. Is this x? Yeah, move it over. I'm going to get -5x's. Is this x? Yes. I'm going to get positive kx's. That's got to go. Why am I doing this? I'm going to show you in a second. How do I get x on its own? Anybody know? Big brain move here. Can't divide by x because then it'll move it over here. You have to divide everything by x. Gone. But now that's divided by x. That's divided by x. That's a mess. You don't want to divide. You don't want to multiply. You don't want to add. You don't want to subtract. This is more than Algebra 1. We're going to factor. This is Algebra 2. Do you see how x is in one spot now? Because I factored it out. That's why you get all the x's on one side, so you can take all the x's out. Now, pause. Yeah, and you can see that k can't be 5. We'll see that in a second. Hold on, okay? If I had x times 7, wouldn't you divide by 7 to get x on its own? I'll say it again. If this was x times 7, wouldn't you divide by 7 to get x on its own? This isn't x times 7. It's x times this. So what are we going to divide by? That. Now, why was getting x on its own going to help us find what k couldn't be? Do you see what k can't be? What is k not allowed to be? If x is a real number, if there is a number that exists for x, what k can't be? What can k not be? Can't be 5, because why? because then we're dividing by 0, and a number divided by 0 isn't a real number, right? So k can't be 6 because this will never be 1. Stop trying to make that happen. And then it turns out x wouldn't work either if k is 5 because you get undefined, right? That's the one. That's one of the hardest ones. Are you ready for one of the easiest ones? Okay, I'll tell you when we get to it. Just be patient. I'm squaring this entire side. That's legal. I'm treating it like it's one idea. What does it mean to square something? Yeah, so it's not just 1 squared minus x squared. That's not what this is, right? It's this. I'll explain. 1 times 1. Yeah. 1 times negative x. Negative x times 1. We're going to get negative 2x's. And negative x times negative x is positive x squared. Right. Are you seeing it? Can you visualize in your mind's eye? If you can't, I'll just write out what it means. 1 times 1. Negative x. That's negative 2x. Positive x squared. Okay. So this is x squared minus 3x. Subtract 1. We're here. Are you seeing it? Subtract 1, it's gone. Subtract x, everything's gone. We cool with that? X squared minus 3x's. X could be 0, or x could be what? Now, here's the problem. We got 2 answers because quadratic, right? But was the original problem a quadratic? So we shouldn't have 2 answers. We did this squaring thing, which actually does change the problem. Because when you square something, it could have started out negative or it could have started out positive. You don't know, right? After you square something, it's hard to tell whether it started positive or negative, right? So what we need to check is, do one of these solutions actually not make sense? Well, let's plug in 3. What's 3 plus 1? What's the root of 4? What's 1 minus 3? Oh, that doesn't work, does it? So 3 doesn't work. What about 0? That's root of 1, 1 minus 0. This is the real answer. This is an extraneous solution. What we did was an approximation. We actually did change the problem by squaring. That's why I don't, That's why I don't recommend squaring things. Because 1, you do it wrong all the time. You square this and you say it's 1 squared minus x squared. No, you forgot the middle, right? But also, when you square stuff, it sometimes creates extra answers. It does. You have to understand that, because squaring obscures where it came from. Was it positive or negative first? I don't know. If I say 25, did you know whether I squared 5 or negative 5? No. Okay, cool. Oh my God, we're in the spicy questions. For those of you that want an A+, you don't want an A+. Stop dividing by stuff here. You can't divide those out. If you do that, it removes some of the answers. Stop doing that. Okay, that's all I want to say. Oh yeah, you're right. All right, I'm going to do it. Why is the sum and the product negative a over b or negative over a and negative c, right? Oh boy. Okay. Best of luck to me. So imagine that this was our quadratic, all nice and factored, right? What are our answers? X equals and x equals negative 3. So what is the sum? Well, it's 2, I'll do negative 3 plus 2. It's negative 1, right? What's the product? Negative 3 times 2, which is negative 6. The what is actually happening under the hood is far more important to focus on, okay? Right. So, let's see where this came from. X squared plus 3x minus 2x minus 6 equals 0, right? That gets us x squared plus x minus 6 equals 0. We said the sum of our answers, this thing, right, should be negative b over a. Negative 1 over 1, which is negative And we said the product should be C over A, which is negative 6 over 1, which is negative 6. First off, did it match up? We did, right? Right, negative 1, negative 1, negative 6. So it works, right? The question is, well, the numbers we have here, are they identical to these numbers here? The signs are different, right? You see how this is 3 and negative 2? Yeah. Oh, sorry, no, signs are totally the same. My bad. What I'm trying to say is this. Point up, are these the same? This is the same as that. No, they're opposites, right? So, to get your answers from this, you have to flip the signs, right? Yeah. If I flip the signs here, if this is negative 2 times 3, I get negative 6, right? But if I flip the signs for my answers, that's what I'm really looking at, right? Do I also get negative 6? What's 2 times negative 3? Negative 6. So flipping the signs, the difference between our answers and what goes here doesn't change anything, right? If you change both the signs, it's still they're not the same. But what about the sum? If I change these add to what? 1, right? They add to 1. But if I change the signs to get my answers, do they add to 1? No, they add to negative 1. Changing the sign doesn't matter when you're multiplying. Changing the sign doesn't matter when you're multiplying. But changing the sign does matter when you're adding. This gets you 1, that gets you negative 1. So if these guys, the things we have here, add to 1, well, we really need negative 1 because our answers are going to be the opposite sign. You got to change that, right? It will affect it. If these guys here is negative 6, our C value, right? If this is negative, will changing the signs change whether it's negative 6? No, not at all. So products, switching signs, it doesn't change your answer, right? Negative 2, positive 3, doesn't matter if you change the signs. But the sum, it will matter. Negative 3 plus 2 or negative 2 plus 3 will not differ. Now, why is it divided by A? Here's why. What if I had a number in front of this? That's going to change things, right? It's going to like do this or something, right? Well, can I just divide everything by 5 right at the get-go? I can. So what's going to happen? This is going to be over 5. It's going to be over A. And so is this, right? So that's the ideal. You can always divide by A to get rid of the thing in front, and then your answer will just be this and this, right? That's the idea. Now, that was very quick and dirty. That was not teaching, right? But that's the concept. Changing the signs matters for the sum, because which one's positive and negative will change the outcome. Changing the signs for the product doesn't matter. If one's negative, it's going to be negative. What's up?
How do you know when you use negative A over A instead of negative B over A?
All right, this is a little confusing. Position 2. Position 2. All right, so when we're talking about standard form of a linear equation, that's this. That is your slope. We proved that previously, right? When I'm talking about this stuff, I'm not talking about linear equations. I'm talking about quadratics. And yes, it is standard form for the field, right? Sum is negative E over A. This guy divided me by A to get rid of this, right? Right? It's going to change the sign. Product divided me by A. Let's get rid of that.
So what's 1 squared? You have to use negative B.
Yeah.
Okay.
Yeah, it just so happens using the same symbols, A and B, and it's kind of sloppy. Yeah. I just actually noticed that right before we did it. So yeah, this is talking about slope or standard form. This is talking about the sum and product. It just so happens that we're using the same letters. Position 1. Right. That was 10. We've done 8. We've done 10. We got plenty of time. Do you want to do 4, 5, or 11? Yeah. 11. The intermediates are tough. The basics are pretty easy though. Does anyone want to see any of the basics on 11? I'm here in 11.4.2. What about any on the first page? First page is really easy if you know how to do it. It's really hard if you don't. All right. What about the most common mistake? You know what I get the most common answer for this one? The most common answer I get is x squared plus 25. Why is that wrong? They forgot to distribute. We will get x squared. We will get plus 25, but what are we going to get in the middle? Minus 5x and minus 5x, right? So we get x squared minus 10x plus 25. This will be x squared plus 10x plus 25. This will be 9y squared plus 49. But what's the middle going to be? Negative 21y and another negative 21y. Are you seeing that? 3y minus 7, negative 21y, negative 21y. So for this one here, it's 9y squared minus 42y plus 49. So again, you just distribute. You have to write it twice. That's what squaring means. And you just do what it says. I'll do it slowly on this one. Big mode. Squaring means this, right? 9y squared. Stop forgetting the square. Eli. Kitson. This is 21y. Isn't this also 21y? It shouldn't shock you that we get the same thing twice in the middle, right? Because it's a square. You're going to get the same thing twice. And then last but not least is 49. Hey, guess what? It's the same thing as the one above it, except it's positive in the middle. Because two positives will always multiply to a positive, and two negatives will always multiply to a positive. But they'll add to negatives or positives. Watermelon? You got the good stuff. All right. Stop getting these wrong. Stop. Right now. I'm tired of it. Square of a binomial. It's saying, can you turn it into this? It has to be the same thing twice, right? So fam, if I did z and z, that looks promising, right? But what would I need here? A positive and a negative. Will that be the same thing twice? Impossible. No. No. Comma, so it's not a double negative. All right, we would need R and R. What do we need here for it to be the same thing? 5. Now the question is, yeah, it gets 25, but does it also get 10? Yeah, it does, so we're right. Yes, we can write it as a square. It is a perfect square. If you haven't noticed, the pattern is 5 squared, 5 doubled. Is this 10 squared and 10 doubled? No, this one doesn't work. 10 times 10 doesn't get you 400, and we need that to get 20, right? 10 and 10, 2 negatives, so no. Sorry. 20 times 20 in theory works, but will 20 and 20 make 20? No, it'll make 40. All right. 11-2-1. Camden, McFalls, Kale. What are these? What is this? What are we? What are we? This is a difference of squares. Do you see how it's 7 squared and t squared? See how it's the difference? Difference of squares always factors to what, everybody? Well, it's got to be t and t. Pretend you don't know anything. Good job. You're really convincing. T and t. What numbers multiply to get negative 49? 7 and negative 7, right? Hey, look. T times t gets us t squared. 7t minus 7t goes away. No middle. Negative 49. It works. What do we call these? Conjugates, yeah. We need opposite signs so that the middle goes away. And it needs to be the same number so we get squares, right? So I need the same numbers but opposite signs because this is a difference of squares. This is 6 squared and this is 3x squared, right? So I need 6 and 6, and I need negative 3x and positive 3x. Do you see how middles go away because we have conjugates? And we get negative 9x squared and positive 36? Incredible. Incredible. Okay. Who is squeaking? You were tapping. It was Koa? Koa the squeaker? Oi! Are these squares? No. What are they? A difference of cubes always factors like this. Binomial or trinomial? We need x minus something. This is x cubed, right? What number do you cube to get 1,000? 10. All right, let's use our brains. X times what gets you x cubed? X squared. Do you see how it's this guy squared? Negative 10 times what gets you 1,000? Positive 100. Do you see how it's this guy squared so that we get cube, right? Now, problem. Do you see how this gets us 100 x's? That's a lot of x's. I don't want 100 x's. This is going to solve the problem for me. So what goes here to get us negative 100 x's? Because I got 100. I need negative 100 x's. Positive 10 gets us negative 100, but not negative 100 x's. I need negative 100 x's. Yeah, I need 10x. Hey, look, it's quadratic. What do you know? Did you notice that it's these two put together? There's a pattern. A difference of cubes always factors to this. A squared, b squared, plus these two put together, ab. We only need one minus sign. Okay, that's it. We just need one minus thing to make things go away. You guys like having like 12 minus signs here. Stop doing that. Oi. Oi. What are these? What are these? Cubes. What number cubed is 27? So 3r. What do you cube to get 64? Yeah. 4 times 4 is 16, times 4 again is 64. So there we go. And it's a sum this time, isn't it? Okay, fam. 3r times what gets us 27r cubed? 9r squared. Hey, it's this guy squared again. What do you know? What do you know? 4 times what gets us 64? Hey, look, it's that guy squared again. Do we want this to be negative? Right here. No, because that would get us negative 64. Why would you do that? Do we want this to be negative? No, it would get us negative 27. Why would you do that? Where does the negative have to go? Yeah, and here's why. Check it out. This is a problem. We get 48 R's. How do I get negative 48 R's? 4 times what gets you negative 48 R's? Negative 12 R's. Or, yeah, X's or whatever it is, right? See how I have negative 48 and positive 48 R? They go away. I win. Hey, did you notice that this is the middle again multiplied? 4 times 3 times R? But we needed negative to make things go away. There is a pattern. A sum of cubes, because that's what this is. It's a sum of cubes. Will always factor to a sum of A and B, A squared and B squared to make cube, and then we need minus middle. But it'll always factor this. That's a nice little pattern, huh? Super useful. Agreed. Prime factorization. Guys, what is this? It's cubes. I'll prove it to you. This is 3 squared cubed plus what cubed? Try again. 2 cubed is what you meant, yeah. Right? It's a sum of cubes. Do you see it? Something cubed plus something cubed. Okay, so what's the something? What's 3 squared? So this is 9 cubed plus, what's 2 cubed? 8 cubed. Hey, we know how to factor that. Isn't that going to factor to 9 plus 8 times 9 squared, right? To get us a 9 cubed. What's going to go here? 8 squared. So we get 8 cubed, right? We distribute. And what's got to go in the middle? Definitely minus 9 times 8, right? So now all we got to do is just do some simple math. This will be 17 times something. And that'll be the factorization of this awful huge number. 17 times something, right? This is 81 minus 72. That's going to get us 9. And then 9 plus 64 is 73. Hey, look, both of those are prime numbers. We did it. That's the only way to factor whatever that is. Like, it'll only be 17 times 73. You'd have to guess and check forever to find that, right? What's up? That is negative 9 times 8. And the reason is this. See how I get 9 times 8 times 8? See how this gets us minus 9 times 8 times 8? It's these guys together again. What do you know? Yeah, crazy. Okay. Just using the pattern or what? Just like finding that number and breaking it down slowly. Does that mean it's easier or it's just the only way you know? One of the ones I gave you was pretty easy to break down manually, but this one would have been awful. You had to figure out 17 goes into it, or 73. So if I gave you 730 plus 490 is going to be 1,000. 12. Oh no, I lost it. 17 times, hold on, 730, 40, 490, 730 plus 490 is 11, 12, 20, 12, 41. So if I gave you this, you would be able to figure out that 17 goes into this. No. There are other numbers I gave you that were like way easier because they were like super, super even, and it's because I didn't think when I changed the numbers. But like, yeah, in theory, this should be hard to do. The reason this is hard, or not the reason it's hard, what you're doing right now, breaking down some really big number into prime factorization, is what keeps your credit card information safe. The person who's supposed to know how to de-encrypt the credit card has the magic numbers. Okay, so we're talking like massive numbers. We're talking like with hundreds of digits, right? And it's like factor it. There's only one way to do it, right? It's like really awful prime numbers. So guessing and checking takes computers a long time, right? So if someone knows it, it's instant, right? Oh, it's 17 and 73, right? But if they don't know it, it's really hard to crack. Problem is, if we have quantum computers eventually become like more mainstream, they can check, this is an oversimplification of this, but they can check all of the numbers at once. And so it takes them exactly one try to get it. And then all your credit card information is out there. Here's the fun fact. We don't have quantum computers on the regular right now, but your credit card information is already out there because our society has decided that in order to build the economy, we're going to let the credit card information get stolen so that you can pay people to protect it or find it. And that moves the money around, and that's how the economy works. So here's the problem. Capitalist society requires you to have debt because money does not, like, the way you use money in a capitalist society is not literally, I have this money. It's about moving imaginary money around. So if you participate outside of that, you're going to have way less spending power than everybody, which is a problem because the society assumes you're going to have that spending power. So it's a very bold idea, and it's a great strategy, and I did it for as long as possible, and I'm sure you will too. But ultimately, that's not how it's built. Capitalism also requires slavery to exist somewhere in the world for it to function, so that's a fun one. Look that one up. I don't know. Anyway, let's go on to this. There have to be poor people in order for capitalism to work, so that's moral. All right, anyway, this thing. How do we get rid of the denominator and make it not nasty? Root 6 over root 6 won't change anything, but we will get 3 root 6 over root 36. What is the root of 36? 3's divide out, and we get this. Isn't 3 over 6 just a half, right? Half of root 6. Don't tell me you're going to multiply this by the 5th root of 9 over the 5th root of 9. The last one worked because the root of 36 is a nice number, right? If you multiply by the 5th root of 9 over the 5th root of 9, what are we going to get on the bottom? The 5th root of 9 squared. Yeah, you need 5 9s to root this nicely, don't you? So here's what we're going to do. We're going to give it 4 more 9s. And now we've got the 5th root of 5 9s being multiplied. Guess what that is? It's just 1 9. Agreed. Multiplicative 5th, right? Okay. Down here, problem. If you times it by itself, top and bottom, you're going to get middle crap, and it's not going to go away. So what do we do to get rid of middle crap? Times it by the conjugate. Oops. Top and bottom won't change anything. It'll just get, make different perspective. And what do we get? Pause. Save yourself time. One times 1 is 1, right? This is negative root 5 when we times it by 1, right? But isn't it going to go away? So why even write it? You know what happens when you times conjugates? You get a difference of squares. We get 1 squared and we get this squared. Right? Isn't root 5 times root 5, 5, and we make it negative? Yeah, you get it, this guy squared and this guy squared, but it's negative. Difference of squares. That's the shortcut. So now this becomes 2 minus 2 root 5 in the top, and we're never going to get rid of that. But the bottom's just minus 4. If you want to simplify, you probably should. I didn't divide out the negative in the bottom. If you want to, you'd have to make these negative, that positive, and this positive. I don't know. It's up to you. So, on this one, we're going to practice doing this mental math in our head, because we know when we times by the conjugate, we're going to get difference of squares, right? So, what are we going to end up with on the bottom? We're going to end up with 3 squared, which is 9. Right? We're going to end up 3 squared. Junk, but they go away. And we get this times itself. So what is 2 squared? 4. What's the root of 7 squared? 7. And it's a difference, right? Difference of squares. The top we just distribute. 3 root 7 plus 2 times 7. Because root 7 times root 7 is 7. Now we clean it up. That's 28. If we subtract it from 9, we get negative 19. Save yourself some writing out. You know the stuff's going to go away. If you're guessing and checking because you're like, I don't know how to actually do this, I'm just trying to figure it out, you need to show all your work so you can find out right where you goofed. But if you know how to do it, you can trust yourself. You know there's going to go away. They're difference of squares. Middle goes away. So I write it. Keeper goes away. Keeper. Negative 4 times 7. All right. We're feeling great. We're feeling amazing. We are almost done with the basics on chapter 11. Cubes are the hard part, right? That's the hard part of chapter 11. Everything else is pretty easy, right? It's the cubes. So this is really easy. Do not do this the way we did that one problem in class. That one problem in class was an advanced problem. This one isn't even an equation, right? If you had to factor this, like no one showed you how to do this yet, how would you guess to do it? That gets us A times B.
Both positive, and just put the numbers in the opposite spots.
Yeah, we need a 5 here, so we get 5B, right? And then we need a 2 here to get a 2A. Oh my God, 5 times 2 is 10. It worked. This is to set you up for bigger and better things. That's what a basic problem is. Some basics are really easy, some basics are hard. It just depends on the topic. They loved it so much, they gave it to you twice. X, Y. Hey, look, that's negative 24, isn't it? We win. Okay. Wow. Are you ready to go after an A? We've already got the C, essentially, if you can do this on the final, right? Or if you've already turned in 2 pieces of evidence. So, Wayne, the final. So, yeah, cool. Putting all our eggs in one basket, always a good strategy. I remember learning about that. That's what they said. Is it a square of a binomial? In other words, is it the same thing twice? It is. 3y and 3y, right? What do we need here and here if it has to be the same thing? Is it double negative or double positive? It's double -5, isn't it? Do you see how we're going to get -15 and -15, which gets us that -30 as well? Yep, it is a perfect square. It is. What do you know? Wayne, you like Punnett squares? You like Punnett squares. Well, I've got good news for you. We're about to do a Punnett square. Wayne has requested Punnett squares because, as you just heard, Wayne loves Punnett squares. What's the area of this box? B squared. What's the area of this box? Try again. I moved. Got him. What's the area? They're the same. This is AB and this is also AB, isn't it? Do you see that the entire thing is A plus B squared? A plus B times A plus B. That's the area of the whole thing. Aren't all these added up equal to the area of the whole thing? Hey, we just proved that identity. When you square stuff, you get these guys and double the middle. It's a square of a binomial. Not a difference of squares. Middle does not go away here because it's not a minus, right? And we're not squaring the whole thing. We're squaring individual things. Okay, questions about that? I can turn the box. Wayne loves Punnett squares. The rest of you guys are all on your own. All right, turn the page. In your head, I'm not your mom. All right, 30 plus 1 times 30 plus 1 is what 31 squared is, right? All right, I guess we'll do it in our head a little bit just because I don't want to write this down. 30 times 30, what is it? Hey, aren't we going to get like 30 twice? Isn't that 60? And aren't we also going to get 1? Pretty kooky. 299 squared. How can we think of that? Times 300 minus 1. So we're going to get like 9 with 1, 2, 3, 4 zeros. We're going to get negative 300 twice. That's negative 600, right? And we're going to get plus 1 because negative 1 times negative 1 is plus 1. So 8, 9, 3, 9, what? Okay, sorry, I'm having a time. 8, 9, this is, no. It's happening. 8, 9, 4. No. Please help. There we go. Oh, you can't see anything. Okay, that really didn't make any sense. 90,000 minus 600 becomes 89,400, right? Right, because we add 600 back, you get 90,000. And then add 1. Sorry. I was having trouble with the commas. I'm really bad with commas, guys. Have you guys noticed that? Like when it comes to okay, good. I've done it a lot in Algebra 1. Like, commas are stupid. It's helpful, but I'm just really bad at it. All right, what is this? It's a basic problem in disguise. It is. What number do you square to get 121? Conjugates, right? Middle goes away. Yeah. This right here is kicking everybody's butt. Do you know why? 800 isn't a square number, neither is 72. Oh, you'd be wrong. Paula, you would be wrong. What common factor to 872 share? Why share? Why share? I can take out an 8. I'm left with 109. Are 109 square numbers? While we're taking stuff out, why don't we take an x squared out? Right? Why not? Why not? Why not? So what we're left with, after we take out x squared, is we have 100x squared. Well, that's 10x and 10x, right? Are you following me on that? Maybe you're not. Maybe you're not. Hold on. I can feel it. I can feel it. All right. Slow down. Take out 8x squared, and we're left with 100x squared minus 9y squared. Are you seeing it now? Minus or plus 3y minus 3y. That's the idea. This is a difference of squares now. Right. Cool. It was in disguise, Wayne. Should we just keep doing one after the next? Okay, whatever. Oh, I missed. We want to know this. Here we go. Ooh, you could do that. You definitely could. It would save you a lot of writing. I would recommend it. If you understand what it means. Highly recommend it. Isn't this just this? Now, normally this would not be a good thing because we have to times these in like, right? But what do we know? So this becomes 3086358025, according to them. And then we get this twice, right? So that is, comma, comma. This is 100,000. That's 10,000. That, when we add it together, gets you 1,000. That, when you add it together, gets you 100. That, when you add it together, gets you 10, and that adds 1. So what's our answer going to be after we add on another one from this? Wait, we already did that. We already did it. We already did it. It's right there. Right, it's right there. Just add 1 on all these. 6 ones, right? Ah, 1, 1, 1, 1, 1. That's a 1. Are these perfect squares? Yes. Do you know what number squared gets you 3 to the 8th? What do you square to get 3 to the 8th? What do you square to get 2 to the 6th? What is 3 to the 4th? Three times 3 times 3 times 3. So it's 9 times 9, right? 81. This is 8. Hey, isn't that a difference of squares? Hey, you factored that really awful number. Wayne has an easier method, I'm sure. Do you know what this is? It's a difference of squares. Isn't it? Isn't it? Well, wait a minute. As much as possible? Could we be missing something? Can we factor it more? We can factor this one. Why can't we factor this one, though? Why can't we factor this part, though? We can definitely factor that. Can we factor this more? No. Is this a difference of squares? It's a sum of squares. You can't factor a sum of squares because you'd have middle terms, right? This one we can factor. What does a difference of squares factor to? What do difference of squares always factor to? Yep, plus 2 minus 2. So the middle goes away. We're never going to get opposite signs here. So we're stuck. This is factored as much as possible. Stop forgetting to do that. Occasionally, and I don't remember what I have in the final, I put it where neither of these are differences, and you're just stuck there. So that's kind of fun. But I don't remember what's in the final. What are these? What is this? Difference of cubes, except 2 isn't a cube number. Neither is 16. Foiled again. They're squared. Not squares. That's a square, but is this? No, because it's odd. It's got to be cubes. So what's the deal? Yeah, you could, but we're not going to. Easier is to factor. What common factor? And z cubed, right? Why don't we write it like this? Now we have our difference of cubes. 1 is a cube number, right? Isn't it just 1 and 1? 8's a cube number, negative 8. Negative 2 and positive 4, right? Oh, and don't forget z and z squared. Are you following me? Right, a squared, b squared, right? It's a difference, so the minus sign goes there. What goes in the middle? Plus 2z times 1, 2z. It solves this problem. 4z squared, negative 4z squared. Did it. The hardest part of this test is the cubes. What's weird about this? Come on, look at it. What's weird about it? There's a lot of negatives, right? Can we just times everything by negative 1? No, it's not an equation, but we can factor out a negative. Now we have this. This is actually not a difference of cubes. It's a sum of cubes, isn't it? So how do we factor it? Well, keep the negative outside. It's going to be a squared, b squared. Do you see how that gets us back to a cubed, b cubed? Positive 2, positive 4. And what goes in the middle? Minus 2ab. Because that solves this problem. 4ab, negative 4ab. It's these guys together again, right? Cool. Oh my. We're going to get 4 different bubbles. Interesting. What are these? It is. However, it's both, actually. It's both. What's easier to work with? Squares. So let's treat it like a difference of squares first. This is x cubed plus 8 and x cubed minus 8. Right? Right? Now what are these? What's that? What's the one? No, it's not a difference. It's a sum of cubes. And we can do that. What's this one? A difference of cubes. So we're going to get this and this, right? X plus 2, x squared plus 4 minus 2x. X minus 2, x squared plus 4 plus 2x. Got him. I'm going to pause there, okay? Let you guys digest. Right, x cubed, 8, and then these guys together. Got to be minus. X cubed, negative 8. These guys together, got to be plus. 4 factors. You want it or no? How bad do you want it? You want it? No? Okay, we don't have to. No. You want cubes to go away, cube roots. So you need something that cubes it. Here's the hint. Do you know what this is right here? That's what that is. So if we times it by this, It's actually sum because I wrote it backwards. We'll get this. And why is that good? Because it essentially takes all this stuff and cubes everything. Gets rid of the roots, right? So if this is this part, what's A? What do you square to get 9? What's B? What do you square to get cube root 9? Cube root 3. AB. So what do we need to times it by? We need to times it by 3 plus the cube root of 3. Top and bottom. Let's save ourselves some times. What happens when you times all this and times all that? You get this, right? The bottom is going to become 27 plus 3. Yes. Do you see how b squared, what do you square to get cube root 9 is this? So this is a and b. That's what we need to times it by. Because when we do that, we get cubes, and it cubes everything. That's awesome, right? So this is going to get you 27. Junk that goes away, right? Blah, 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 blah. But really, we know that it takes whatever a and b are, right? And it cubes them. So when we do this, we get this, right? So what are a and b? 3 and this. If we cube it, we get 27. If we cube it, we get 3. So the bottom's 30. Saves you a bit of time, huh? What's the top going to be? 12 plus the cube root, or 4 times the cube root of 3. I'll write that better over here. Don't forget to simplify. What common factor do they all share? 2. So this becomes 6 plus 2 cube root 3 all over 15. Not so bad once you see how it works. However, it's good luck remembering that on Friday or something, right? But that's the idea. This one actually sucks worse. If I had this on the original, right? I had something plus root 7. What would you times by? Something minus root 7, right? Wouldn't you? The conjugate? Okay, so we're going to times by the conjugate. It's something minus root 7. It's something minus root 7. What's the something? Apparently this. Yeah, you don't change the signs on all of them. Turns out. Root 2 minus root 5 is just some number. Treat it like it's a number, right? It's some weird number. And then it's plus root 7. So we'll do some number minus root 7. That'll be the conjugate. Okay. Are you ready? I'm not even going to worry about the top. I don't even care. Who cares? Root 2 times root 2 is 2. Root 2 times negative root 5, it's negative root 10. Root 2 times this, negative root 14. Negative root 5 times everything. We're going to get a lot of them, aren't we? Negative root 5 times this is negative root 10. Oh, no, that doesn't go away. That's supposed to happen. You're going to be left with 1. Don't panic. So we did this, and we got negative root 10 again. Okay. What's negative root 5 times negative root 5? Positive 5. Negative root 5 times negative root 7, positive root 35. Okay. Then we get root 7 times everything. Positive root 14. Negative root 35. Yay! And negative 7. Top is 2 times all that, right? If you want to just do 2 and all that in parentheses. Love that. Well, well, well. You're not wearing your hood correctly. You're supposed to have the fur tucked in. Hey, look. That's convenient. Even the 2, the 5, and the negative 7 go away. It's kind of wild. Hey, Grace, we just did your favorite problem. So what's the bottom going to be? It's going to be 2 times all this junk. I'm going to write it because why not? That's the top, right? And the bottom is just going to be negative 2 root 10. Do you see how I have 2 of them? Darn, it's not deradicalized. I can just times by root 10 over root 10, right? This is literally like the first one we ever did. Root 6 in the bottom. So now we get 2 times, oh, I didn't mean to make that big. No mistake. What's root 10 times root 10? Negative 20. Oh, look, that divides out. We're trying to get an A in less than 3 hours. That'll be the title of this video. Clickbait off the rails. Except it's not clickbait, it's real. It's real. It's totally real. Grace, your hair looks different. It's not wet. Welcome to my ASMR. It'd be better if you could see what was happening at the same time. Can you identify that sound? Leave a comment. It's good for the algorithm. Ball. Okay. What it's trying to get you to see here is really good, but the way they do it makes you just want to do it from left to right. So I'm going to cross it out. There's a way to factor this. 19 is a factor, 13 is a factor, 7 is a factor, 3 is a factor, and 21. But we're just not going to do it, okay? Do I have to do 11, 5, 4? All of you? Wayne taught me everything I know. What about 11.55, which basically is the same thing as 11.54? Should we do that one? We can. Would you like to? Okay. P, Q. Negative 3, positive 5. Wait a minute. I get negative 15. Where's the negative 15? Oh, no. What if I put a minus 15 there and a minus 15 there? Okay, so we're not timesing to 0. That's kind of unfortunate. We're timesing to negative 15. That means this and this could be 1 and negative 15, right? It could be negative 1 and 15. It could be 15 and negative 1. It could be negative 15 and positive 1. It could be 3 and 5. It could be, well, one of them's got to be negative. It could be 3 and negative 5. It could be 5 and negative 3. It could be negative 5 and positive 3. Oh my, that's a lot of options. Write down all the options for P and Q. If this is 1, what does P have to be? Negative 4. If this is negative 15, Q's got to be negative 12. Are you following what I'm smell what I'm stepping in? Negative 1, that's got to be negative 6. If it's 15, it's got to be 18. If it's 15, it's got to be 10. If it's negative 1, it's got to be 2. If it's negative 15, it's got to be negative 20. If it's 1, you got to be 4. If it's negative 3, you got to be negative 8. If it's 5, you got to be 8. If it's positive 3, you got to be negative 2. It's negative 5, you got to be negative 2. Ooh, doubles. Did that one. If it's 5, it's got to be 0. Oh, with negative 3, it's got to be 0. It's negative 5, it's got to be negative 10. And if it's positive 3, it's got to be 6. There are all the options. I did it. We're done. Spicy. Yay. All right. It is 8:30, basically. We have done quiz 11. We have done quiz 10. We have done quiz 10. We have done quiz 10. That was the quiz 10 we did. And we have also done quiz 8. Basically, not all of them, but like basically all of them. The only thing left is 5 and 4. Do you want to do the rest of 8? Do you want to do 5? Do you want to do 4? What are you going to do? You want to get out of here? I don't care. It's up to you. We did 4, right? Didn't we do 4? You did 4. 5 is elimination substitution, right? 5 is substitution system of equations, right? 4 is what if you had expressions with multiple variables and you had to plug in numbers? Mm. You're welcome. Yeah. Then don't do it. I probably know you know how to do this if you can do 5 or 8 or 10 or, right? Just skip it. It's fine. The final basically only helps you. It really does. I have to say with an asterisk because there are some people that are like, I actually don't know what I'm doing. I'm just copying down the notes. And when it comes to the final, they can't do anything. That's a problem. Here's the thing, though. Usually those people turn in their stuff really late. And have I graded late work? No, because I've been really sick. So their grade can't move down because it's not moved up yet. So it'll be fine. What? Am I? No? The what? How's it set up? We got a kickback with the boys. So on Friday, you're gonna be here. I'll be here. There's gonna be a thick test in front of you. We're talking about like 3 C's. And then you will do as much as you can for the ones that you want to get evidence for, that you don't think you have enough evidence for yet. Someone just farted. That was crazy. You're going to do some of the ones that you're like, I don't know if I've really, I don't want to leave that blank. Mr. Mack might think I don't know how to do it. But in general, you're going to do what you can. It'll be fine. It'll be fine. I don't like doing written finals at the end of the year, but I'm not in charge this year, so that's what we're doing. And I'm trying to make it as fair as possible while also holding you accountable. You're going to be fine. I promise you. Okay? You'll be fine. If you're already failing and you're like, will the final make me fail? No, you're already failing. Now, that doesn't mean like I'm failing because I turned in a ton of late work and Mr. Mack hasn't got to it. I mean like failing like I have not turned anything in. Why is my grade enough? Right? Like, yeah. You probably got it all banked on the final, don't you? Right? But the rest of you that did all the homework and the quiz, you're going to be fine. It's 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 going to be fine. Okay, so take the final, do really well, show me you can do it without notes, and I'll be like, look, Grace is so cool. And then I'll do like a kickflip. It'll be awesome. Kickflip not guaranteed. That makes sense. You look like a poser. All right, now what? Grace, do you board? Are you a skateboarder? Yeah. She would. Yeah. With a longboard? Dumb. Yeah, that's what you get. Grace, I don't know if you know this about Grace, but like she's kind of gangsta. You know what I mean? Yeah, I know. Yeah, that little bit right there, that's the roots with her skating days and her biking days. Ripstick? So rich kid skating. I get it now. Okay, got it. Right. As seen on TV. All right. What am I doing for you guys? Okay. All right. Jaden's like 4. Barbecue chicken. Say it. Say it. Don't say it. Don't say it. All right. Bam. Are we doing all the basics? Is that what we're doing? What do you want, Aubrey? You times to get rid of fractions because it's an equation, right? Here's what I'm going to do. Here's what I'm going to do. Here's what I'm going to do. I'm going to take this top equation, and I'm not going to times by 13 first, just because I know you guys get scared if I don't do this first. Right? How about we get all our y's together? Now it's times by 13. 80 and 24 makes 104. Notice anything about this equation? Yeah, divide by 4. It doesn't 4 go into 104, right? It goes into 25 plus 1 time, right? So 26. So this is this. Okay, cool. That's equation 1. Got it? Equation 2. Times everything by 13. You could divide by 5 right now if you really wanted to, but like, I don't know. I'm not afraid. It'll be fine. 50 and 15 is negative 65. 13 and 25, 250 plus 75. So that's 370, 325. What do you notice? You could have done it here and it would have made your life a lot easier, but I didn't. But do you see how you could divide that by 5, that by 5, that by 5, and then new times by 13 is easy? Yeah, I know. This is negative 3x. This is negative 13. This is 5 is 65. Equation 2. Do elimination, do substitution? I don't know. X equals negative 1 minus 26. You plug it in here. There's a ton of negatives and it does things. Better. Better is good. I'm looking for better, yes? Adeline Monaco is going to be here at 7 a.m. All right. Because your mom would be so mad. What do you mean she has to go to the school right now? What you're doing is logic. Sometimes you're playing Monopoly and you're like, what are you guys doing? You can't just do that. And they're like, Grace, we've been playing Candyland the whole time. And you're like, oh my God. That's how the world's going to work when you get older. You're going to be playing Monopoly. I'm doing what makes sense. But everybody else is just making stuff up, but they're in charge. So, sorry. Yeah. There are worse games. Yeah. You have to remember, when you're trying to make change in society, the people in charge are often playing Monopoly. So you can't just be like, well, let's just do what makes sense. First mistake. This is true. But we're not playing Monopoly. That's right. Tell them. Preach. Preach. Guys. It is if you know what you're doing. What's up? I'm making him stay here. You know how I am. Terrible.
You guys want a hamburger?
Oh.
Give 'em a hamburger. I got it out here. If you're hungry, come on.
Go get him. Go. You can stop eating my Rice Krispie treats. Wayne.
Don't tell Overton, guys.
How's up? Yeah. water break.
Isaac and Herbie did that already. I laughed when I watched the game.
Yeah, good. Mr. Olson coming in clutch. All right, so now you got your mouth stuffed. I'm going to ask you a question. If this were the problem, what's our goal? Say it again? Yeah, find x and y, right? Numbers that work for both. How are we going to do that? We got to get down to one variable, right? Right? So here's the question you guys wanted to see. It's the same logic. Step one, get down to two variables, right? Are you smelling what I'm stepping in? Get down to two variables. And then once it's at two variables, don't you know how to solve a problem like that? Yes, you do. Behind every intermediate problem is a basic problem. So if we can convert this to two equations with two variables, we win. So that's what I'm going to do. I'm going to write that down so you understand what I'm saying. If I can turn this into two equations that have two variables in them, I'm going to write it like this. It's weird notation, but you'll get the gist, okay? I'm actually going to convert this to two equations that have x and z in them. And the reason I'm doing that is because if you notice, I can get rid of y really easily. You guys seeing that? Okay? So here's what I'm going to do. I'm going to take top equation. I'm going to take bottom equation. And very quickly, because we got to get out of here, I'm going to do elimination with them to get rid of one of the variables. Am I going to add or subtract these to make the y's go away? Adam. Be careful. Most mistakes are made here. X plus negative 2x is negative x. Anything plus its negative is 0. 2z plus z is 3z. And 6 plus 14 is 20. So there's equation 1. Yeah, I'll write it like this. Equation 1 is this. Do you see how I now have one equation with two variables? Now I got to do this again to find another equation with the same two variables. It does me no good if I get an equation with x and y, because that won't work with this, right? So I got to pick another two equations. I'm going to pick equation 2 and equation 3 again, so these two. Because after I times this by 3, I can get rid of y again. I need to get rid of y so I get another equation with x and z. So I'm going to do what you, well, no, I'll just do it. I'm going to say you should never do this. You should never multiply in your head. You should write everything down. So I'm going to do that. I'm going to write equation 2. And I'm going to times it by 2. Or sorry, times it by 3. 30 times 3 is 90, so this is going to be 87. And then I'm going to put equation 3 underneath it. Am I going to add them or subtract them to get rid of the y's here? I'm going to add them. Whoops, I missed my circle. So if I add these, careful, this is where a lot of mistakes happen. Negative 11x's, 0 y's, 16 z's, 90 and 11 makes 101. So now I'm here. And this, there's a 1 there, is basically a basic problem. All you have to do is do elimination or substitution to this, and you win. I'm going to show it to you, okay? But at this point, if you've already proven you know how to do a basic problem, like if I started with this, could you solve it? If you've already done it earlier in the test, do I need to see it from here? No. But I'm going to do it, show you it works, okay? So that was step 1. Whittle it down to this. I am going to take the purple equation, and I'm going to write it as x equals 3z minus 20. I'm doing that by adding x over and subtracting 20. Are we cool with that? Are we cool? And I'm going to sub it into the other equation that has x right there. And why is this a good move? Why is it a good idea to switch that out in here? Jaden. Before I had this. One variable, right? That's what he's saying. Negative 33z, positive 220, positive 16z, 101. After I combine them all, I get negative 15, no, negative 17z. After I subtract 210, I get, or 220, I get negative 119. And this looks really scary, right? What times negative 17 gets you negative 119? Any guesses? 7's a good guess. 10 would be too big. 10 times 17 is 170. So it's got to be less than 10. Do you see how it ends in a 9? 7 times 7 ends in a 9, right? So that's a really good guess. 70 and 49. Yep. Z is 7. Now you might think, well, we found one of them. It's just going to take forever to find the others. No, 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 no. If Z is 7, what's X? If X is 1 and Z is 7, this is 14 now. That's 15. 15 minus 9 is 6, right? How do I make that minus 9? What do I plug in here to make this negative 9? Negative 3. So y is negative 3. Got him. 7 makes us 21 minus 20. That's 1. If this is 1 and that's 14, then we get 15 minus 9 is 6. Make it negative 3. I win. Okay. Yeah, I got it right here. You thought I forgot about you? Wayne, you taught me everything I know. Here it is. Oh my God. There you go. All right, fam, anything else I can do? We've got 10 minutes. What else can I do for you? Okay. The what? The what? That's chapter 5. Janice. Janice. All right. At a certain time, Janice notices that her digital watch reads A minutes after 2 o'clock. So here's how I first thought about it when I was just like riffing. Okay, 2 o'clock. That's 120 minutes afternoon, right? Here's A minutes after 2 o'clock. Are you following me? Now, it turns out what I'm doing is extraneous. There's a simpler way of doing it, but this makes sense to me. I think it makes sense to you. 15 minutes later, okay, now we're here, right? 15 minutes later, it is the same thing as B minutes after 3 o'clock. There's 3 o'clock. There's B minutes after, right? She also says A is 6 times B. Now, you might notice if we subtract to simplify, we get 60 and this goes away, right? So I'm just going to do that. That's the simplest way to start it. If you just subtract that, you get 60, right? So elimination or substitution. 6B plus 15 equals 60 plus B. Subtract B's, I get 5B plus 15 equals 60. What's B got to be? Yeah. So what time was it when she looked again? 3:09. Yeah, so the smart way is to just ignore the 2 o'clock thing and write 60 minutes later, it's 3 o'clock plus B, right? But if you don't do that, like I did originally when I was first doing this, I'm like, okay, 120 minutes, 180 minutes. Yeah, works out. How are we feeling? Great, fantastic. can always tell it's cool. Yeah. Yep. Have you ever heard the phrase, played stupid games, win stupid prizes? Yeah. Wayne, I like you. You're all right. You all right. Bye. All right. Are we all good? Turning off the stream. Okay, I'm going to upload the video now, and then I'm going to go home and do a bunch of grading. No. Oh, it wasn't this time, no. Poor Noah.